Hi everyone. In this video, I'm going to introduce the concept of energy. All right, energy is just the capacity to do work. Okay, so whether it's a machine or whether it's a compound or a chemical reaction, and of course we're in chemistry class, so we're going to look at chemical reactions. Potential energy is basically what that says. It's something that has the potential to do work. So it's storing that energy. Kinetic energy is the energy of motion. So this is when a object, compound, whatever it might be, is using its energy, so it's in motion. Just like the law of conservation of matter that we've been studying, the law of conservation of energy states that energy can not be created or destroyed either. Okay, so it has to be released or transferred, but it can't be destroyed, okay, or created. So chemical bonds, like the ones we've been looking at, they store potential energy. So if a compound has lower energy, potential energy, that means it's more stable. So the lower energy that it has, the more stable it is. And if it has higher energy, then of course the opposite. So the higher energy that the compound is, the less stable it is. Okay, so if we have a chemical reaction, and so we have reactants, whatever those might be, and products. Reactions that form products that have lower energy okay, these are favored reactions. Okay, so the more stable, so what we're saying here is the lower energy, the more stable. So if you form a product that's lower in energy and more stable, then more than likely this reaction is going to be more favored. Okay, favored means products because ideally most chemists are trying to form products, right? They don't really want to get back their reactants. They want to form the most product that they possibly can. Okay, and so if you form a product that's lower in energy, then this is going to be more stable, which in turn means that this would be favored. So reactions that form products having lower potential energy than reactants are favored. And real quick, I missed this just to kind of give you an idea. But if you have a hill, for example, and you have a ball on top of the hill, okay, if it's just sitting there, then it has potential energy, right? Because it's not moving, but it's stored. Okay, but if that ball rolls down the hill, then that would be kinetic energy, the energy of motion. All right, so in this video, we're just going to look at the units of energy and do a practice problem. So we've been converting a lot. So hopefully you've learned to convert all sorts of volume and mass, quantities, and now you are also learning, or you've learned how to convert from grams to moles and so forth. So this really just goes along with that, but you need some conversion factors. You need some common relationships. So the units of energy are calorie, abbreviated cal, and joule, abbreviated J. All right. And a calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree C. All right. And so we have a conversion factor for a calorie and a joule. So in 1 calorie, there are 4.184 joules. Okay. If you don't remember, I hope you recall that anytime you have kilo, all that means is 1,000, right? So there's 1,000 joules in 1 kilojoule. Okay, 1,000 cals in 1 cal. Okay, and if you change both of these to kcals and kilojoules, then you still have 1 kcal for every 4.184 kilojoules. Okay, but the main one here that you want to see is for every 1 cal, we have 4.184 joules, or that could be kcals and kilojoules. Okay, so here's a practice problem that we want to work. And I'm going to show you the short way that would make the best sense, but then also kind of show you the roundabout way. That way, if you do that, I want to show you how you still get the same answer and why we can use these conversion factors. So here and here. Okay. We have a chemical reaction that releases 55.2 kcals. We always write out what we know first. So we always start like this, okay? And we want to find kilojoules. So we can either do one step, 2 steps. We've got to figure out our plan. So I'm going to go back, and if you look at your conversion factors, you have a direct relationship. 1 kcal for every 4.185 kilojoules. So this is the simplest way. So if you put 1 kcal here, and you have 4.184 kilojoules, you get 231 kilojoules. Okay, if you're in my class, I do give you this conversion factor, so on the test. Okay, so if you sort of forgot that a kilojoule and a kcal could be used in place of here, okay, if you went the roundabout way, you'll see how everything just cancels. So let's say I forgot about this up here. So I go to calories because I know this. So there's 1,000 calories in 1 kcal. And you should know this just because of the kilo. So you need to know your prefixes. So there's 1,000 cals in a kcal. Okay. And then so I know in 1 calorie, I have 4.184 joules. So I got that from here. Whoops. And then I have 1,000 joules in 1 kilojoule. So this would be the long way if you forgot this. And what I want you to see is why this works just like this. So your answer here would still be 231. Okay, is because ultimately all you end up doing is multiplying 55.2 times 4.184, which was the same thing that you did here. So your 1,000 and your 1,000, they cancel each other. So this canceled, okay, and that's why this works. So if you went the long way and did this, you'd still get the right answer, okay, but you'll see that your joules and cals are going to cancel each other. So you could have just done this in the one step. All right, I hope this helped, and I'll see you soon.